So here in chapter 13.6, we're talking about radian measures. So radians and degrees are two different ways to measure, distances around circles. It also is going to relate a lot to the unit circle section that we have coming up next. So it's important to know what radians are and how they relate to degrees. But again, it's just another way of thinking about degrees. You've probably already on your calculator seen in that top right corner, sometimes it says RAD, which means radians, and sometimes it says DEG, which means degrees. Up until this chapter, it hasn't really mattered much because everything we've been doing in math has been in degrees. But now that we're talking about radians, we need to make sure that this symbol in the top right corner is on the correct setting. So if you're working in degrees, you need to make sure that this is set to DEG for degrees, and if we're working with radians, it should say RAD for radians, okay? If you have it set in the wrong setting, it's going to throw off your answer completely. So you need to make sure it's in the right setting. Otherwise, you will not get the right answer. So what are radians? Well, if we think about, let's take this circle here, and I'm going to find the center of the circle, and I'm going to say that the radius of this circle is 1 unit. Okay, so 1 unit. If I'm thinking about the circumference, we know that the circumference of a circle is 2 pi r. In other words, 1 full rotation around the circle is equal to 2 pi r. I also know that 1 full rotation around the circle is equal to 360 degrees. So we can say that the circumference is the same thing as 360 degrees, right? Both of these represent 1 full rotation around the circle. Now in this case, if the radius is 1, that means that if I plug in a 1 here for the radius, we can say that 2 pi times 1, which is just 2 pi, is equal to 360. And if I go ahead and I divide both sides, not by pi, by 2, this means that we can say that pi represents 180 degrees, right? If 2 pi is 1 full rotation, it makes sense that just 1 pi is half of a rotation. So we know that this is kind of the representation that in radians, 1 pi is equal to 180 degrees. So what we can do is we can use this kind of ratio as kind of like a scale factor in terms of getting back and forth between radians and degrees. So if I have a degree measure, I can multiply it by pi over 180, and that will give me an answer in radians. And if I have something that's in radians, I can multiply that by 180 over pi, and that's going to give me an answer that's in degrees. So this is kind of like our conversion factor here, how we get back and forth between radians and degrees, okay? So, again, if we try to start thinking about degrees and radians, we're going to start this circle. This is kind of a lead into next section, so this is important. Make sure you don't forget this. We know that in degrees, well, here I've got 0 degrees, and here I've got 0 radians. I haven't moved at all. I'm starting here. This is my starting point right there on the circle. That's where we start. Imagine if I make a turn counterclockwise 90 degrees. Well, if I turn this way 90 degrees, this would be 90 degrees. If I keep going and add another 90, this would get me to 180 degrees. And if I keep going another 90, that would get me to 270 degrees. And if I keep going another 90, that brings me all the way back, which we said was a full 360 degrees. Okay, so these are our degrees, kind of our main degrees, but you can have something that's, like halfway in between, which would be like 45 degrees, or you can have something over here, which is maybe 120 degrees. So you can have other points, but just to get us started, these are kind of the main points that we have around the circle in terms of degrees. Let's try to do the same thing with radians, right? We said that to go from degrees to radians, I could use that conversion factor, right? We said that I can multiply everything by pi over 180. And if I multiply everything by pi over 180, that's going to tell me how many radians I'm moving around the circle, okay? So if I move 90 degrees, well, we know that 90 degrees, if I take 90 and multiply it by pi over 180, this is going to be 90 pi over 180. And we know that 90 over 180 reduces to be 1/2. So we get 1/2 pi. And what you're most often going to see here is you're going to see this written as pi over 2, right? 1/2 pi is the same as pi over 2 because we know that multiplying by 1/2 is the same as dividing by 2. So this is going to be pi over 2 up here, right? 90 degrees is the same thing as pi over 2. And then I'm going to go another 90 degrees, and if I take 180 degrees and 180 times pi over 180, well, we know that the 180s will just cross out, and that's going to equal pi. So here, at 180, we have pi. And then I can go another 90 degrees, and we can kind of see the pattern, right? If I add plus pi over 2, plus pi over 2, plus pi over 2, well, 1 pi plus pi over 2 is just 3 pi over 2. And then we can go another 90 degrees, and if I add another pi over 2, that's going to get me a total of 2 pi, which is what we said in the beginning, right? We said that one full rotation is 2 pi r, and since our radius is 1 that we're working with here, the circumference is just going to be 2 pi, okay? So this is kind of a quick conversion going back and forth between degrees and radians, and in the next chapter, we're going to build upon this, and we're going to find a bunch of different important values all the way around this circle, okay? And so we're going to be able to identify the relationship between all these different angles in terms of their radians and also in terms of their degrees. So let's try out some problems just converting back and forth between degrees and radians. Here we're going to convert from radians to degrees. So if I'm converting from radians to degrees, I know that I want to multiply by my conversion factor. So we're going to multiply by 180 degrees over pi. This is going to become 180 over 6 pi. Sorry, we forgot the pi up top there. 180 pi over 6 pi. We know the pi's will cancel, and that just leaves me with 180 over 6, and that reduces to be 30 degrees. So we know that 30 degrees is the same as pi over 6. And so we can even go back to this circle here, and if we put 30 degrees, right, if I travel just 30 degrees here, we know that 30 degrees is the same thing as pi over 6. So we can kind of add to our little chart that we've got going here. And then if I have negative 7 pi over 4, again, I can multiply by the conversion factor. So that's 180 over pi. And that gives me, well, actually, let's do some reducing first. I don't really want to do 7 times 180. That's going to be a bigger number. Let's reduce first. So I'm going to take 180 divided by 4. And maybe you don't recognize it right away, but we can reduce by a factor of 4. But if you don't recognize that right away, you can just divide by 2. So that's 90 over 2. And now we realize, okay, well, actually 90 over 2, I can reduce that further. That's just 45 over 1. So now I've got 7 times 45, and we know that 7 times 45, again, if you're not sure, you can still do it the long way, that's fine. 45 times 7, 5 times 7 is 35, carry the 3, and we get 315. So I have a minus 315 pi on top over 1 pi on the bottom. All right, again, how that worked out, negative 7 times 45 is negative 315. We still have a pi on top and a 1 pi on the bottom. All right, so now that we've got this negative 315 pi over pi, we can just cancel this out, and this is going to give me negative 315 degrees. Okay, so that'd be our answer. Now this one, you might say, oh, well, I have to go 315 degrees around the circle. What we're going to learn next section is that because this is a negative degree value, I'm actually going to have to go the opposite direction around. Okay, so we're going to talk about how to kind of go back and forth between the negative and the positive degrees and which direction that means. Here we're going to convert from degrees to radians, so I'm going to multiply this by pi over 180, and that gives me 270 pi over 180. We know they're both divisible by 10, so that gives me 27 pi over 18. I now see that they're both divisible by 9, so that would give me 3 pi over 2. All right, so 3 pi over 2 is going to be my answer. And that means that 270 degrees is the same as 3 pi over 2. Well, that should make sense because that's what we said we had right here at the beginning. All right. If we look at the last one here, negative 45 degrees, I'm going to multiply this by pi over 180. And we're going to take that negative 45 pi over 180, and I can reduce both of these, let's see, by 5 maybe. So if I reduce both of these by 5, it's going to give me negative 9 pi. If I divide 180 by 5, we get 36. And I can actually keep going with this because they're both divisible by 9 now. So I'm going to divide them both by 9, and we get negative 1 pi over 4. And so negative pi over 4 would be your answer, all right? So that's kind of how you're going to convert back and forth from degrees to radians and radians to degrees. But it's really important to understand this relationship here, okay? Radians and degrees are used to describe the same angle relationships, but just in a different way, okay? So it's important to know whether you're in degrees or whether you're in radians, and again, how to get back and forth between those two angle measurements.